Hello friends, good morning. So today we will be actually starting with our topic discussion. So I hope all of you listened to the previous strategy session. I request you all to go through the strategy session first before joining this class. If you have already watched, then fine. Or you can continue with the session today and later you can watch the strategy session. So today we'll be actually starting with our topic. Okay. As per the strategy session, we'll be starting with our topic today. So today we'll be starting with the first topic, that is probability. Okay, friends. So let us start. I hope everyone is able to see the screen. So, like I told, today we'll be discussing about probability for IIT JAM and CAT-B. Okay. So we are going to learn probability with respect to the examination point of view, that is required for IIT JAM and GAT-B. All right, friends. So before that, I want to inform you about one thing. So the Chandu Biology classes is coming up with one of the new course, that is secure below AR 100. Okay, in GAT-B and QAT PG 2025 and also in IIT JAM. Okay, so this is a rank assurance program. Okay, the fees is 21,999, that is almost 22,000. What is the USP of this course? So coming to this course, it has a well-defined 8 months plan. Okay, it is both having interactive live sessions and also if you mix the live sessions, you can even watch the recorded sessions. And we will be providing well-crafted PPTs, which you can see. That has been the hallmark of Chandu Biology classes. Expertly designed study material. Okay, and 13 chapter-wise and 10 mock test. Okay, we will be providing sectional test, that is chapter-wise test and also 10 mock tests, full-length tests, and individual attention will be provided to every students, not just the core paper, even the mathematics, that is my chapters. I mean the mathematics required for both GAT-B and IIT JAM will be covered. And when it comes to core paper, you will be having 13 chapter wise and 10 mock tests which will be taken. I mean the classes will be conducted by Chandrasekhar sir, Dr. Chandrasekhar sir, okay, who has got all India rank 2 in life sciences. Okay, CSIR net life sciences, and he is a PhD from Indian Institute of Science, which you must be knowing. Anyways, Chandu Biology classes is coming up with one of the very good courses, that is secure below AR 100 in GAT-B and IIT JAM and QAT, that is Common University Entrance Test for post graduation 2025. Okay, so when will this course start? This course is starting from next week, that is October 1st. Okay, friends, I request you all to enroll to this course and start immediately so that you will be able to maintain the momentum and be regular with the classes and start immediately so that you stay up to date with the classes. Okay, if you start late, don't have that catching up mindset. Okay, because if you miss the classes and if you join late, you will be in a little disadvantageous position where you have to catch up with the classes. But in case you enroll before October 1st, you'll be given a discount where you have to pay only 22K, not 26K. All right, friends, and you will be able to join the class from first day itself, and you can watch all the live sessions, and even if you can watch a recorded sessions any number of times so that you can revise better, and you can start giving the test as and when the chapters are completed. All right, friends. So having said this, that is, I'm reminding again, the course is starting from 1st October, friends. 1st October 2024. All right, friends. So let us continue with our discussion. That is, today we are going to talk about probability. Okay. When it comes to probability, it's not new to you. So most of you or all of you would have studied in class 10th. Okay, class 10th level. But here it is little advanced level, but the questions are very simple. But questions from probability are coming every year. So probability is a high yielding topic, but it's a very simple topic. So today we are going to discuss what? We are going to discuss only the basics. Okay, today we are going to discuss only the basics. That is after 10th, that is after 10th level or plus 2 level. Okay, so today we are going to discuss only the basic terminologies associated with probability, friends. That is, we are going to learn only the basics today. So in the upcoming sessions, you will be able to answer any questions from probability. For that to happen, you should know the basics first. Be it any chapter, you have to know the basics first. So assuming that all of you have studied probability in class 10th and plus 2 level, okay, I understand at least some knowledge of probability you must have had, but thinking that you have zero knowledge of probability, I am starting with certain basics of the probability so that each and everyone, those who have forgotten probability, can also be able to tackle the questions on probability. So today we are going to discuss what, friends? We are going to discuss the basics of probability. So today what we are going to cover, that is basic terminologies related to probability. That is basic terminologies. Today's topics will be mainly based on terminologies. Okay, terminologies with respect to probability. Okay, what are we going to cover? We are going to cover what is a trial, what is an outcome, what is a sample space. Okay, next we'll be covering what is a random experiment. Okay, because in the question they will give in a random experiment such and such a thing happening. What is the probability of the event? Okay, so you must know what is a random experiment. Without knowing what is a random experiment, you can not be able to solve the question. That is why these terminologies become very important to understand. It is very important to understand. So please pay very good attention to my words. Each and every word which I say is very important. That is, if you know the basics, tackling the subsequent questions. I mean, subsequent classes, when I give questions, you'll be able to solve. Okay. We'll be including the PYQs also in our sessions. So please pay attention to each and every word I say in the classes. What is an event? What is a mutually exclusive event? What is exhaustive events? That is, first we are going to learn what is an event, what are the types of event, that is, what is mutually exclusive event, then what is exhaustive event, and all these things. Next, what is partition of sample space? Okay. In an experiment where there is partition of sample space, they will give the question like this. In an experiment where there is a partition of sample space, okay, such a thing happened. What is the probability of a certain event? In that question, if you don't know what is partition of sample space, you will not be able to get the correct answer. That's why it's very important to understand. It is very pertinent to understand what is partition of a sample space. But before that, we must know what is a sample space at all. So each and every term, we will go slowly and learn what is a trial, what is an outcome, what is a sample space with examples. Okay, so please pay attention to each and every word which I'm going to tell you now. Now, first thing we are going to learn is what? What is a trial? Okay, what is a trial? Okay, now experiment. Suppose there is an experiment. What is an experiment? What are the type of experiment we are going to conduct? Okay, so suppose I throw a coin. Suppose I throw a coin or toss a coin. Okay, so how many times I do that? So each time I do that, it is called a trial. Okay, each repetition of the experiment. Each repetition of the experiment. Your experiment is what? It can be tossing a coin. Tossing a coin is an experiment. Tossing a coin is an experiment. If you throw it once, that one time, that is the number of times you do it, it is called a trial. So one time if you do, that is called a trial. Second time if you do, that is called a trial. So each repetition of the experiment. Okay. Suppose, for example, you are given a bowl of laddus. Okay. Eating laddus is an experiment. Okay. In a bowl of laddus is given. Okay. Bowl of laddus is given. Here, eating laddus is what? Experiment. But each time you are allowed to eat only one laddu. Okay. So, how many repetitions are required? Suppose a bowl of laddus contain 50 laddus. Each time you are supposed to eat only one laddu. So, you will eat one laddu. Okay, that is one trial. So you will eat second laddu, that is a second trial. Like that, how many trials are required? 50 trials are required to eat 50 laddus. 50 trials are required to eat 50 laddus. Okay. So eating laddus is an experiment, but each repetition, that is in each repetition, I mean each trial, you are going to eat only one laddu. So eating one laddu, that is one trial. Okay. This is the meaning of a trial. I hope now it is clear. What do you mean by a trial? Okay. So tossing a coin is a trial. So eating a laddu is a trial. What's an experiment? Eating all the laddus is an experiment, but eating one laddu is a trial. Okay. So now throwing a dice. You must have played snake and ladder game. There you get what? Dice. Okay. There you get dice. Okay. So when you throw a dice, you may get number one, you may get number two, number three, number four, number five, now up to number six. Okay. You may get any number, but each time you throw it like this, each time you throw a die, that is called trial. Okay, each time you throw a die, that is called a trial. Okay, so each repetition of the experiment is a trial. So playing with the die is an experiment, but each time you throw it is called trial. How many times you repeat? One repetition is called one trial. Second repetition is called second trial. So that is the meaning of, friends. That is the meaning of trial. I hope now it is clear to you. When I say in the question trial, you will be able to answer. You will be able to understand. You will be able to comprehend. So comprehending the question is very important. That is understanding the question. Comprehending means what? Understanding the question is very important. When you understand the question, you can answer the question because you will get clarity about the question. To get clarity about the question, each and every term associated with the topic should be clear. That is why I am covering this, the basic terminologies. Okay, these terminologies are there in your NCRTs, which you have studied in class 10, 12th and all. Okay, so those terminologies are very important to understand. And we are just revisiting those terminologies. So trial means each repetition of the experiment, friends. Okay, so like that, let us move forward. Next, outcome. Okay, outcome. Next word is outcome, friends. What is this? Outcome. So what do you mean by outcome? So a possible result of an experiment. Okay, a possible result of an experiment is called outcome. So what do you mean by that? Okay, suppose I toss a coin. Suppose I toss a coin, I or throw a coin. So okay, suppose our captain, Indian team captain Rohit Sharma goes for a toss and it tosses a coin. Okay, what is a possible outcome? It can be head or it can be trial. So the result of the experiment, the possible result of the experiment is called outcome. Okay, outcome. So you must have done a lot of experiments in the lab and all these things. So what is the result you get? That is called outcome. So like that, when we toss a coin, there can be two outcomes, right? It can be head or it can be tail. So it can be head or it can be tail. I'm talking about unbiased coin. I'll tell you in future sessions. I mean, I'll tell you in future slides what is biased coin, what is unbiased coin. Suppose it is an unbiased coin, you'll get either head or tail. So getting that head or tail is called outcome. Okay, friend, don't get confused. No need to get confused. Outcome means getting either of them, not both. Either means either head or tail. Okay, so what we get? Okay, what is a possible outcome? Okay, what is a possible outcome? That is called what is a possible outcome or what is a possible result of an experiment is called outcome. Okay, so suppose I throw a die. What are the outcomes I can get? I can get either one or two or three or six. That's whatever term. You can get either one, two, three, four, five, six. So among these six, either one of them you can get. Either you can get one or two or three or four, five or six, like that. So this is the meaning of outcome. A possible result of an experiment is called outcome. Okay, a possible result. Okay, but actual result what we get, that is not called outcome. For that we use another word that is called event. Possible result is called outcome. Actual result what we get. So before the experiment, we are telling this. Before conducting the experiment, I am telling. After conducting the experiment, we get actual result. This is possible result. So possible result means before the experiment. So before the experiment, what are the possible results we may get? I'm telling we may get probability. We may get, that is called outcome. But after the experiment, what we get, that is not called outcome. We got the actual result, that is called event. Okay, friends, we'll understand this when I talk about event. Next is sample space. Okay, the set of all possible outcomes of an experiment. The set of all possible outcomes of an experiment is called sample space. It is denoted by capital S. It is denoted by capital S. So all possible outcomes of throwing a die is all possible outcomes of throwing a dice, that is capital S sample space, is it is denoted within a set, that is it is denoted within a set of all numbers, that is 1 2 3 4 5 6. So one of the outcomes can be 1, one of the outcomes can be 2, one of the outcomes can be 3, one of the outcomes can be 4, one of the outcomes can be 5, one of the outcomes can be 6. These are all possible outcomes. When you sum of all possible outcomes, sum of all possible outcomes, that is set of all possible outcomes. Okay, set of all the possible outcomes. So when throwing a die, the outcome can be 1 or 2, 3, 4, like I told, like that. I told you earlier. Okay. So when you put together all these, okay, what are the total outcomes that you can get? Okay, what are the total outcomes, total possible outcomes, set of all possible outcomes? that is called sample space. So when you throw a die, what are the possible outcomes? All the possible outcomes that can be there. That is 1, 2, 3, 4, 5, 6. So that is the meaning of sample space. Suppose I toss a coin. Another example is suppose I toss a coin. Okay. So for here, sample space will be head, tail. Okay, head, tail. But outcome can be head or tail. But sample space is head or tail. Sample space is both head and tail. See, outcome can be head or tail, but sample space is head comma tail. That is, sample space means what are the outcomes it can be getting. While throwing a coin or tossing a coin, what are the outcomes we may get? We can make it head, we make it tail. So if you put together set of all the outcomes, that is one is head, another one is tail. If you put together what are the outcomes, that is head, comma tail. So that is the meaning of sample space. Okay. Suppose we write on examination. Okay. Outcome can be we can pass or we can fail. We can pass or we can fail. But what are the two outcomes? That is pass or fail. If you put together, that is sample space. Exam. Before the exam, I'm telling what it can happen. Outcome can be before the exam. Possible outcome can be pass or fail. But sample space is if you put together this, it can be pass or fail. Pass, comma, fail. This is sample space. Okay. There can be two outcomes. One is pass, another one is fail. But if you put together these both, you will get sample space. Okay. So it is total of all the outcomes. Okay. Sum total of all the outcomes. That means you're not going to add it. You're not going to add 1, 2, 1 plus 2 plus 3 plus 4 plus 5, 6. No, it's not like that. You're going to put together all the numbers. That is 1, 2, 3, 4, 5, 6. So that is the meaning of what? Sample space. Okay. Another example I can give you. Okay. Another example I can give you is suppose you go and play a cricket game. You go and play a cricket game. Okay. So what are the possible outcomes? Suppose there is no weather interruptions. What are the possible outcomes? Cricket game. What are the possible outcomes? You win or you lose, or if the scores are same, that can be a tie. So here the possible outcomes are three. So win or lose or tie. These are all what? These are all outcomes. Okay. The set of all possible outcomes. If a set of all these, it can be win, lose, or tie. This is nothing but what? This is nothing but what, friends? This is nothing but sample space. This is denoted by S. Now I hope it is clear to you. What do you mean by sample space? Okay. When I told R, that is outcome. When I told comma, that is sample space. Okay. It can be win or loss or tie. That is possible outcomes. That is favorable outcomes, what we want. Okay. But what can be the actual outcomes? What can be the actual outcomes? That is event. But total of all the outcomes, set of all outcomes that can be possible. That can be possible. Either it can be a win or lose or what? Tie. That is sample space. Okay. Some sort set of all possible outcomes. Possible outcomes can be win or loss or tie. Set of all possible outcomes can be win, comma, loss, comma, tie. That is sample space. Now I hope what do you mean by trial, what do you mean by outcomes, what do you mean by sample space. I hope it is clear now to you. So trial means suppose I told you that you're eating a laddu. Each time you take and eat a laddu, that is called trial. Okay. Next outcome. Okay. Outcome means while tossing a coin, if you get hit, that is outcome. While tossing a coin, that means the possibility of getting hit is called outcome. The possibility of getting a tail, that is called outcome. But while tossing a coin, there are what are the possibilities of getting? What are the possibilities that are there? That is, you can get head or tail. If you put together head, comma tail, that is called sample space. Sample space means set of all possible outcomes. That is, we are talking before the experiment. That is, what is possibility of getting that outcome? That is called possibility of getting something. That is called what? That is called outcome. But after the experiment, you get it. That is called event. Actual result which you get. That is called event. Okay. So probability means what? First of all, we have to define what is probability. Probability means the chances of something happening or not happening. Okay, the chances of something happening or not happening. So after telling the terms, I wanted to define probability, but here only I'm telling you. Okay, what do you mean by probability? Probability means chances of something happening or not happening. What is the chances of something happening or not happening? Okay, whether it can happen or not happen. That chances is nothing but probability. Okay, next event. They're telling, see, you don't have to remember these definitions, but whatever is in the NCRT, I have picked up. Any subset of a sample space or a collection of outcome of an experiment is called event. Okay, is called event. So event means event means here tossing a coin is a trial. Tossing a coin is what trial, and getting head or trial is an event. So I told you what do you mean by trial? Each repetition of the experiment is called trial. So each repetition, each trial, what when you do, each trial when you do, you will get something. Okay. So experiment, I'll write here experiment. Okay. Before, after. Before we have possibilities. Before experiment, there is something called possibilities. That is called outcome. What are the possibilities? That is called outcome. After experiment, we get actual outcome. Actual outcome is what? Actual outcome means the result what we got. Okay. That is possible result. Possible result means you can say outcome. Actual outcome or actual result means it is called event. Okay. So when you toss a coin in one trial, the outcomes can be head or a tail. The outcomes can be head or a tail. That is called outcome. But after tossing a coin, what we actually got? Okay. After conducting the experiment, what we actually got? Suppose we get head. That is an event. Getting a head is an event. Or getting a tail. That is not trail here. It should be tail. Okay. Getting a tail is an event. Okay. Suppose you played a cricket game. Winning or losing, that can be an outcome. Win and lose, if you put together, that is sample space. Okay. Next, after playing a cricket game, if you win, that actual result which you got, that is an event. If you lose, that is an event. If you match is tied, that is an event. Okay, friends. So that is the meaning of what do you mean by outcome? What do you mean by sample space? What do you mean by event? See here. This is cricket game. It's an experiment. So before experiment, the outcomes can be win, loss, or tie. Win or loss or tie. Okay. What is the sample space? Sample space here is win, comma, loss, comma, tie. Okay. This is the sample space. After the game, actual result. Suppose it is a win. This is an event. Or suppose it is a loss. This is an event. Suppose it is a tie. Then it is an event. All the three cannot happen. Okay, all the three cannot happen together. Either it can be win or loss or tie. It cannot be win, loss, or tie. Okay, you won the game, that is an event. You lost the game, that is an event. You are tied the game, that is an event. Okay, all the three if you put together, that is sample space. Is it clear, friends? Is it clear, friends? So I hope you understood what is a sample space, what is an outcome, what is an event. So this is outcome. This is outcome. So don't worry about this definition. You have to understand what do you mean by an event. That's all. Event means what we actually got. So after tossing a coin and getting a head, already got the head. That is an event. Or after tossing a coin, we got the tail. That is an event. That's all. Probability of getting a head or tail, that is an outcome. That is, you may get or not get. Okay. But you actually got it now. The experiment is over. We got the trial is over. We got something. That is event. After performing the experiments, we may get something. That is outcome. Okay. That is still possibility. That is, you will get or not get. We don't know. The possibility of getting that. That is outcome. Which you actually got. That is event. Okay, throwing a trial, the dice is a trial. Okay, like I told you, and getting one out of 1, 2, 3, 4, 5, 6. If you are getting one, that is event. If you're getting two, that is also an event. Okay, you may get one or two or three or five or six, any of the numbers. Any of the numbers which you get, that is an event. Actual result which you got, that is event. That is the final result which you got, that is event, friends. Okay. The possible result is outcome. Final result which you get, that is event. Next, what do you mean by random experiment? Okay. Next, what do you mean by random experiment? Till now, what all we studied, friends? We studied what is a trial. We studied what is a sample space. Before that, we studied what is an outcome. Outcome means the possible result. Sample space means all the results put together. Then final result which we got, that is event. Okay. What is it? Each repetition of experiment is called trial. Okay. Possible result. Possible result means outcome. All outcomes, if you put together, is called sample space denoted by capital S. Final result which we get, that is called event. Okay. Now we are talking about experiment. Now what do you mean by random experiment? What do you mean by random experiment? But before that, I want to tell you one thing. There is, when we spoke about coins, there is something called biased coin and unbiased coin. Biased, the word itself says it is in favor of something. That is, both the sides can be head and head, or both the sides can be tail and tail. So here, if you throw the coin, you will get head only because both the sides are head. Or if you throw the coin, you may get here. Here you will get head itself. Here, if you throw, you will get tail itself. Unbiased means one side is head, another side is tail. Okay, here you may get head or tail. Okay, so in most of our experiments, we are talking about, when I'm talking about tossing a coin, we are talking about unbiased coins. What coins, friends? Unbiased coins. Okay, so now you understand in random experiment. Okay, in a random experiment, what do you mean by random experiments here? An experiment is called a random experiment if it satisfies the following two conditions. It satisfies the following two conditions. Following two conditions, friends. So, what do you mean by two conditions? What are those two conditions? It has more than one possible outcome. It has more than one possible outcome. That is, it should not go had a, not should not have only one outcome. It should have more than one outcome. That is, if you throw a biased coin, there is only one outcome. You will get head always. Okay, biased coin that is having head on both the sides, you will get only one outcome. Even if you throw 1,000 times, you will get head only. Even if you throw 1 crore times, you'll get head only because both the sides are having head itself. Okay, biased coin. Or if a biased coin where there is tail on both the sides, even if you throw thousands of times, crores of times, you'll get tail itself. There is only one possible outcome. But unbiased coin, if you keep throwing many times, you may get head for sometimes or tail for sometimes, or it keeps changing. Okay, unbiased coins means you may get either head, either tail, or anything. That is, it keeps changing. You will get head or a tail. There is only two possibilities. Nani? I mean, here only one possibility. Biased means only one possibility. Unbiased means two possible outcomes. That is more than one outcome. So that is the meaning of random experiment. If you throw a dice, there are six outcomes. How many outcomes are possible? If you throw a die, either it can be one, two, three, four, five, six. Six outcomes are possible. So an experiment which is having more than one outcome. Okay, an experiment which is having more than one outcome. Suppose while playing a cricket game, what are the possible outcomes? It can be win, loss or tie. Even if it is a test match, there is another possibility, that is it can be a draw. Okay, so that is called random experiment, where result is still not clear. The result cannot be decided. Okay, result cannot be decided in the beginning of the experiment itself. So in biased coin, if you are throwing, which is having head on both the sides, result is already decided. Okay, that is not random experiment. That is, there is no arbitrariness there. Okay, already you will know that even if you throw 1,000 times, you will get head itself always. So random experiment means it is having more than one possibility. Not one possibility, more than one possibility. More than one possible outcome. Okay, like I told cricket game. Okay, more than one possible outcome. It can be a win or loss or tie, or it can be a draw. Okay, I'm talking about test match. If you talk about test match, okay, there can be a win or draw or loss or tie. Correct? No, there is more than one possible outcome. So it is a random experiment. Playing test match is a random experiment. Up till 5 days or up till 3, 4 days till the match ends, we never know whether it is a tie or loss or win, or 5 days completed, still we not got result. That is a draw. Okay, so that is why it is a random experiment. Now, another condition is, this is first condition, having more than one possible outcome. It is not possible to predict the outcome in advance. It is not possible to predict the outcome in advance. 100% we can't predict the outcome. Okay, suppose when you talk about biased coin, I told both the sides are head. Suppose a coin is having both the sides head. Here definitely we can say, okay, definitely we can say, if you throw the coin, what you will get? You will get head always. You will get always. You will get head always. That is, you can definitely predict the outcome. Okay, definitely predict the outcome. So that is the meaning of what? That is the meaning of it is able to predict the outcome. So that is not called a random experiment. But when you can't predict the outcome, suppose you're tossing a coin. Okay, tossing a coin means you cannot predict the outcome. Okay, it can be either head or tail. Okay, that is lucky. If you're getting in your favor, that you're being lucky. That's all. If you're throwing an unbiased coin, if you're getting head, if you call the coin as you will get the head, you will after tossing a coin, you're telling that I will get head. If you get head, that you're lucky. That's all. Otherwise, it can be falling out as tail also. So you're not able to predict. You're just what? You're just what you're doing. You're just trying to use your luck. That's all. Okay. So you can't predict the outcome in advance. Suppose throwing a die. Okay, you're throwing a die. Okay, you can't predict 100% that you will get one only. You cannot predict you're getting one only. You can get either one or two or three or four or five or six. So that is the meaning of telling can't predict the outcome in advance. Suppose we're playing cricket game. Okay, suppose we're playing cricket game. Okay, you cannot predict the outcome 100%. You can have a confidence that we will win, but you cannot say 100% will win. That is okay, having confidence, but the result can go either ways. You can either win or lose, or it can be tie or it can be drawn. That is the meaning of telling cannot say with surety that you're going to win. So 100% you cannot say. Suppose you can say Roger Federer and Nadal is playing. Okay, okay, you cannot say either Roger Federer will win or Nadal will win because either both are equally competent. Okay, I'm giving one example. That's all. So you cannot predict the outcome in advance. That is the meaning of random experiment. One thing is what? It is having more than one possibility and it is not able to predict the outcome in advance. So in all our questions which we are tackling, okay, whatever the experiment that we are doing is a random experiment. Okay, that's why we have to find the probability for them. Okay, what we are going to deal, we are going to deal about random experiments only in our questions. Which are the questions which we are dealing or which are the PYQs that has come, it is based on random experiments only. So that for that questions we have to find the probability difference. Next thing, when you spoke about events, I told events means results. So when you spoke about events, you have to talk about two types of events. That is, one is mutually exclusive events, another one is exhaustive events. So I'll end up this class after talking about these two events, because in the next class we'll continue with some more terminologies. Okay, with some more terminologies, that is partition of sample space and all these things. So now I'll tell you in brief about what is mutually exclusive events and what is exhaustive events. See, here we have something called exhaustive events, another one is called mutually exclusive events. When it comes to mutually exclusive events, okay, there should be no commonalities. Suppose there are two events, event 1 and event 2, there should be no commonalities. Okay, suppose there is event 1. Event means what? We are getting a result, final result. Event 1, tossing a coin and getting, tossing a coin, tossing a coin and getting head. Event 2 is tossing a coin and tail, getting tail. Okay, getting tail. So the intersection of the events, intersection means suppose I write E1 and intersection E2. If there is nothing common, that is what we call it as empty set, we represent it by phi. This is called phi. This symbol is called phi. So E1 intersection E2, okay, is a null set. Phi means it is null set or void set. Okay, null set or void set. Or it is an empty event. Okay, or empty set. So E1 intersection E2, okay, if it is coming as there is nothing common between the two, that so event 1 we got what? Head. Event 2 we got what? Intersection. Event 2 we got tail. What is common here? Head and tail? Nothing. Zero. Nothing is common. So this is called mutually exclusive events. Suppose there are two balls, ball 1 another two, bowl two. Okay. Here we are having laddus. Here we are having pakodas. Here I lift something, I get laddu. This is event one. Here I lift something, I get pakodas. Okay. This is E2. So what is common between these two? There is nothing common. This is laddus, this is pakodas. So such events, even and E2, then they are called mutually exclusive events. Then they are called mutually exclusive events. Okay, friends. This is the meaning of mutually exclusive events. Okay. So this is the meaning of mutually exclusive events. So don't worry about the what? Don't worry about the definition and all. So these are given. Actually, this is academically given. What is the meaning of mutually exclusive events and all these things? You need not learn the definitions. Only thing is you have to understand. In the question, if they give what is mutually exclusive event, you should be in a position to answer. I mean, in question, they will not ask you what is a mutually exclusive event. They will give in a mutually exclusive event, certain thing happen. Then what is the probability of getting this? That time you should know the definition. You should know understand the definition of mutually exclusive events. Otherwise, you can't solve that question. That's why I'm telling you mutually exclusive event means when two events happen. Okay, if you combine those two events, there is nothing common between them. Okay, there is nothing common between them. Okay, if there is no commonality, intersection, that is intersection means if there is anything common or not. There is no common means that is empty set. So in mutually exclusive events, there are two events E1 and E2 such that there is nothing common between them. So such events are called mutually exclusive events. There is no common means nothing common means between E1 and E2, nothing is common. Nothing is common. So such events are called mutually exclusive events, friends. Such events are called what? Mutually exclusive events. Like I told, laddu and pakodas. If you pick one bowl, every full of laddus, you will get laddu only. If you pick another bowl full of pakodas, you will get pakoda only. Between laddu and pakoda, in that event 1 and event 2, there is nothing common. Here you will get laddu, here you will get pakoda. Okay. So there is nothing common between laddu and pakoda. So the final results, there is nothing common between the two. Such events are called mutually exclusive events. So we'll be learning more about events in the upcoming class. That is in the next class. We'll be learning about independent events. We'll be learning about exhaustive events and all these things. Okay, friends. So now I'll wind up the class. I hope the session was useful. So please go through the session once again. If you have any doubts, you can ask in the comment section. Okay. So we discussed some terminologies today when it comes to probability. Probability, we learned about what is a trial, what is an outcome, what is a sample space, and we learned about what is an event. And we also learned about what is a type of event. One of the event is mutually exclusive events. Next class, we'll be learning about what do you mean by exhaustive events, and also we'll talk about partition of sample space. So probability of an event is always lies between 0 and 1. Probability can never be negative. This you must remember. I'll wind up by telling this. Probability, if we talk in terms of numbers, can never be can can never be negative. The value always lies between 0 and 1. It can be 0, can be equal to 0, or it can be equal to 1, or it can lie between 0 and 1. But it can never be less than 0, it can never be greater than 1. Okay, never be less than 0, never be greater than 1. In terms of percentage, if I say, it lies between what? 0% to 100%. Okay, it lies between 0% to 100% in terms of percentage. Okay, in terms of value, it lies between 0 and 1. It can be 0. Probability if an event is 0 means the event is not happening. Probability if event is 1 is 100% the event is happening. Event is happening. Probability that is 0.5 means it may happen or it may not happen. That is 0.5. Okay. So the value of probability of an event is lying between 0 and 1. It can be equal to 1, but never less than, or it can be equal to 1, but never greater than 1. It can be equal to 0, but never less than 0. All right, friends, I'll wind up the session now. We'll meet in the next session. I hope the session was useful. Okay. Please give your feedback in the comment section, friends. Please give your feedback in the comment section. And also, if you have any doubt, please ask in the comment section. All right, friends. Thank you. Take care.